Okay, I hope you had fun with that. So one more step that's important for, well, many applications, like in our case, the chatbots, is being able to link entities in a document to a knowledge base. And here is kind of a good news, bad news situation. The good news is that entity linking, so grounding text segments to a knowledge base, is included in Spatie with a complete API. But what's lacking is, like for all the other steps that we've done, a pre-trained model. So you cannot just load a model, for example, for linking entities to DBpedia or to Wikidata. This is something that's sort of still in development. There are instructions on how to train it on a knowledge base. For example, Wikipedia or Wikidata. But running those is a bit involved. Now you have to download a complete dump of the data set, and processing it is going to take quite a bit of time and memory. And there are some development versions. So for example, there's a project here where they have a model trained on Wikidata. And then again, you load your web model, you load an entity linker, and then you can process a document. And now we can find the entities that were linked in that document. So for example, here in the document, it found two entities that it linked to Wikidata. Pirates of the Caribbean linked to Q194318, and Sylvester linked to Q125-25597. So bottom line, you can use Spatie. It's especially interesting when you have your own knowledge base and you want to train a new linking algorithm on it. Then obviously you have to train it from scratch. And it also has built-in support for training it on existing knowledge bases. But it's not as easy as with all the other steps we've done, that you just load the default pipeline and it has the linker already built in. So this is something they are still working on. In general, this is quite a hard problem, this entity linking, to do reliably. So for DBpedia, for example, the Spotlight tool that we talked about earlier, at least for now, is probably an easier way of linking the entities. So let's talk about pipelines. I've showed you pipelines in the beginning, how they look like in the gate system. And there's a similar idea with pipelines in Spatie. So I told you a few times already, when we load the model for, let's say, English, this model includes a default pipeline. And you can see some of the steps here. In the default model, it has a tokenizer, part of speech tagger, parser, named entity recognition. So each of these components in the pipeline creates on this document structure various entities. So the tokenizer will create the document tags. The tagger will create the part of speech tags, and so on. So each step in the pipeline will, on that document, create these additional annotations. And you've seen earlier how to access them and how to print them out. So once you have the pipeline, it doesn't mean that you are stuck with the predefined one. You can define your own pipelines. And of course, you can also define your own processing steps inside the pipeline. And I'll show you how this works next. So in the model, when you load a predefined model, it has the pipeline definition and the metadata. So for example, using a tagger, a parser, and a named entity recognition defines the pipeline to use. And then what happens is when you process a document, it will apply each component in turn on that pipeline, and then the pipeline is done. You can load the default pipeline and then selectively disable steps. Let's say you don't need the parser, so you don't want to waste time, processing time, memory for running it. You can disable it as shown here. And you can add a new component to the pipeline. So here we're using the predefined pipeline, but we are adding a new component. And in this case, we are adding it as the last step in the pipeline. For the full documentation, you can look here, but let's look at an example as a kind of a dummy component that doesn't really do anything, but just prints out a statement depending on how many tokens there are in a document. So again, what do? We have an existing pipeline, the one we get from the default NLP model, and we want to add another step at the end. And what the step at the end does is simply looking at how many tokens there are. And if it's less than 10, it will say, this is a pretty short document. So this is our new component that we want to add. Now it's just a Python function. We are loading the pipeline in the default NLP model. We are adding my component as a new step at the end to the pipeline. For debugging purposes, we just print out the pipeline and then we process it like before. So what's going to happen? Now you can see what's printing it out. You can see it's printing out the tagger, the parser, the named entity recognition. That's from the default pipeline. And now it's adding this print info component. In there, we have, again, some debug output. After tokenization, this document has 5 tokens and printing out the part of speech tag and then saying, because there were less than 10, this is a pretty short document. So obviously, this isn't doing anything sophisticated, but if you want to add some further processing step, for example, you're doing something in your chatbot to answer questions, you can add this as a new component to the spaCy pipeline. So to summarize what's going on, we have our NLP model, which is language specific. We used English for all the examples, but you can experiment with some of the other languages. For each language model, it has configuration, metadata like the pipeline, and language specific data. So in there are these pipelines with the individual components, and they are creating this document. So this is the structure that contains all the results from each of these processing steps. And yeah, this is what we look at after processing the document. We're going through the structures that were created. So tokenizer creates tokens, part of speech tagger creates the part of speech tag on tokens, named entity recognition creates these entities and so on. So this we can then later extract for all kinds of applications. Okay, so I have a few concluding remarks in the next part, and I'll see you then.